Okay, I'm feeling lucky after that last problem. So let's take this one on. Solve sine 2 theta plus sine 4 theta equals 0 for theta between 0 and 2 pi. Note that these arguments 2 theta and 4 theta, what we've done is multiply the theta by a number bigger than 2. So we've compressed the sine and the cosine. So there's a lot of wiggles now in between both of these functions between 0 and 2 pi. And what does that mean? I think that means there's a lot of solutions to this particular problem. Let's see. So this is problem 43, page 503. You have 45, if I can read my own handwriting. Very similar problem to this. So let's just go have some courage and take it on. Gonna do it in a blood color here. So you might remember some time back we were talking about different types of difficulties in trigonometric equations. And in that case, we were looking at a problem, and I said, at least what we've got going for us is that the arguments of all the trig functions are the same. You've got issues when they are not, and we now have a problem to deal with where the arguments are not the same. And I'm really influenced by the problem that we just did, which looked a little similar to that. And so I'm going to go exactly the same way, and I'm going to use the sum to product formulas, because the sum to product formulas will take this sum and it'll turn it into a product. And when I set a product equal to 0, all I have to do is look for those values of theta that set any factors in that product equal to 0. Let me do it and you'll see what I mean here. The product to sum, the product to sum for the sine and the sine, product to sum for the sine says sine of alpha plus sine of beta, and that's what we've got, sine of alpha, sine of beta, is equal to the following product, 2 sine alpha plus beta over 2. I'm just going to hope that this falls onto your slide, cosine alpha minus beta all over 2, right? If you can't see that, I'm going to come right back to it right now. So let me assume that alpha is equal to 2 theta, beta is equal to 4 theta. Let me insert that into this, and I'm going to get the formula sine of 2 theta plus the sine of 4 theta, sine of alpha plus sine of beta, is 2 times the sine of alpha plus beta over 2. Alpha plus beta is 4 theta, 3 theta. Sorry, alpha plus beta is 6 theta divided by 2 is 3 theta, times the cosine, that's what this factor is, of alpha minus beta. Let me just do that like this. I did this earlier and skipped this step. Alpha minus beta is 2 theta minus 4 theta, or minus 2 theta all over 2. Okay, it equals 0. I did this last time and I just kind of skipped through it quickly. The cosine of minus 2 theta over 2, the cosine of minus 2 theta over theta is the same thing as the cosine of theta, owing to the even symmetry of the cosine. So by using the product to sum identity, we've turned this equation right here, sine of 2 theta plus sine of 4 theta, into 2 sine 3 theta times the cosine of theta equals 0. Now, instead of trying to solve this problem, I'm off trying to solve this problem. Okay, and good luck to us, but it's much easier, because what we're looking for is the theta that makes this term, cosine theta, equal to 0, or the theta that makes this term, sine 3 theta, equal to 0. Like I said, there's going to be a lot of them. Let's go look for them here. Let's start with this. Which theta makes cosine theta equal to 0? Because any theta that does that makes this term equals to 0, makes the whole thing equal to 0. Okay, so let's see. Let me just draw cosine theta here between 0 and 2 pi. Starts up here, goes down here, comes back up. We're at 2 pi. Where is theta equal to 0? 2 places. And what 2 places are those? That is pi over 2. Pi over 2? Yeah, pi over 2. And this is 3 pi over 2. So there, we found, there can be a lot of solutions here. I mean, I better put a little green circle around and we'll collect them all up later. Great. So now let me go ahead and solve now. So we've taken care of that. Put that over here. Now, which theta make sine of 3 theta equal to 0 for theta between 0 and 2 pi? So let's see if we can do this. Okay, here's my 2 pi over here. Here's my 0. What's this going to do? Well, let's remember that the period is 2 pi all over omega. And in this case, omega is 3. So there are, if this is 2 pi, there's 2 pi over 3, there's 4 pi over 3. And each one of these is a period of the sine. So the sine will go like this. One up, one down, right there. One up, one down, right there. All right, so now, where are the roots? Well, there's 1, 2, 3, 4, 5, 6. 6 different divisions, equal divisions in 2 pi. So each one of these are 2 pi over 6. So each one of these, this is pi over 3. Yeah. This is 2 pi over 3. Yeah, that is 3 pi over 3, or pi. This is another pi over 3. What is that? 3 pi. So it's 4 pi over 3. And what's this one? Yet another pi. It's 5 pi over 3. Okay, so I think I found them all. The answer to this is there is a set. And that set has pi over 2. It has pi over 3. It has 2 pi all over 3. It has pi. It has 4 pi over 3. I think 3 pi over 2 goes right here. I'm not real sure. And what else do we have? And a 5 pi over 3. I've got the solution just looking at me right here. Let me just make sure that that's the case. I'm going to run and hide if it's not. Which problem are we doing? We're doing 43. 43. How come I didn't get a 0? Oh, I forgot the 0. There's the 0 right there. Let's throw one more in. There's a 0. And then I've got a pi over 3. There. I've got a 0. I got a pi over 2. I got a 2 pi over 3. I got a pi. I got a 4 pi over 3. I got a 3 pi over 2. I got a 5 pi over 3. Easy problem. Good luck to you on problem 42.